It's a science show with amazing science experiments. And the whole point is to inspire children through science and lifelong sparking lifelong imagination and curiosity. All right, so we're going to pass it off to the mad scientist Tony to make things go boom. Technical difficulty, guys. We're just waiting for them to join on. Just give me a second. You guys tell me. Oh, there he is. Is that scientist Tony? We can't hear you. I'm sorry. We can't hear you.
Hear me now?
I can hear you now. We're good.
Awesome. All right. Well, that's what we wanted. Very good. Well, let's go ahead and get started. So, welcome everybody. I am so glad to be here with all of you today. Eid Mubarak to everybody. I'm so glad to be celebrating with you guys. I miss seeing so many of you this year, as I have for many years at the convention in April, and I'm so glad I get to be here with you virtually to show you some really cool experiments. As you heard, today's show is called Things That Go Boom. So, science, of course, is always awesome, but the best kind of science are chemical reactions, and especially chemical reactions that go boom. And that's what we're going to do today, okay? So, we're going to go ahead and get started. So, my name, you can call me Dr. T. As you heard, my name is Tony, right? So, I am Dr. T, your mad scientist, and I am going to show you guys a lot of cool experiments today, okay? Now, normally I have a few rules that I would go over, right? But I trust that you're going to be a very respectful audience, of course, because you are all at your homes right now. But there is one rule I still have to mention, okay? And that is normally my third rule, all right? And it is the most important of all my rules. And this rule still applies even if you guys are at home, okay? And that rule number 3, all right? After rule number 1 about being respectful, rule number 2, raise your hand if you have something to say, right? Rule number 3 is that you must have fun. So no matter where you are, you can't get away without following rule number 3. And I'm going to make sure that you guys don't have any trouble with that, okay? Well, we're going to get started then, okay? So like I said, today's show is all about chemical reactions, okay? And we're going to learn a little bit about them, all right? And we're going to start by learning what a chemical reaction actually is, okay? And we're going to start by learning what a chemical is. So a chemical is a type of substance, and that's just a word we use to refer to basically everything, right? Everything is some kind of a substance. So there's lots of different types of substances out there, okay, guys? So we've got, let's say, one substance right here, which will be represented by my left hand, and another substance right here that'll be represented by my right hand, okay? Now, what my hands represent are something called molecules, all right? Now, molecules are these really, really, really tiny things, and they make up everything in the whole world, okay? So we've got a molecule right here, and we've got another molecule right here. Now, what happens, guys, is sometimes there are certain types of molecules that react with each other, okay? So those molecules come together, and here's what happens. Now, some of you may know that molecules, as tiny as they are actually made up of something even tinier, okay? And that tinier thing is called an atom, A-T-O-M, not like the name atom, okay? So atoms are even tinier. So molecules are made up of atoms. Now what happens is those molecules come together, and then they start mixing together with each other, and this molecule will take some of its atoms and give it to that molecule. And then this molecule will take some of its atoms and give it to that molecule. And now we've got 2 brand new molecules, and they both have different types of atoms on them, right? So that means they must be molecules for 2 brand new chemicals, okay? So that was a lot. So basically, you have chemical 1 and chemical 2, right? Both made of molecules. Those molecules come together. Chemical 1 molecules give some atoms to chemical 2. Chemical 2 molecules give some atoms to chemical 1. And then we have 2 brand new chemicals that are different than the first 2, and then they come away from each other, okay? All right, So now you know what a chemical reaction is. Now, let's get to the fun part where we actually get to watch a few examples of chemical reactions. So, first up, guys, I am getting very thirsty here, right? So I'm going to go ahead and make myself a milkshake. How many of you guys like milkshakes? All right, I knew it, right? So think about your favorite flavor of milkshake, okay? All right, so everybody got to think of it. Everybody knows their favorite flavor now? Okay, now I'm going to show you my favorite flavor of milkshake. Now, here's what's cool about my favorite flavor, guys. It's sort of an instant milkshake, okay? You don't even need a freezer. You don't need refrigeration. It's perfect. Let me show you how it works, okay? And we call it a gloop glop milkshake. So, to make a gloop glop milkshake, which I bet is different than whatever milkshake you were thinking of as your favorite, right? To make a gloop glop milkshake, we need 2 different ingredients, all right? We need a little bit of gloop, and we need a little bit of glop that I have wrapped up right here. Open that up there. Now, I also am going to grab a cup right here to mix it up with. I'm going to set that right there. So first, I'm going to add in my gloop, just like that. All right, and I'll show you guys in a second here, don't worry. All right, and then I'm going to take a little bit of glop, and I will add in my glop, just like that. All right, so got our gloop in and our glop, and now I'm going to take this stick and I'm going to stir it up. I'm going to come around there so I can show you guys up close what my gloop glop milkshake looks like, okay? So let's see. We're going to mix that up just like that. Keep on mixing. And now I'm going to show you my milkshake in just a moment. And we'll keep on mixing here. Perfect. Okay, so now let's go take a look at that milkshake and see. And you guys can tell me if you think it looks good or if you think it looks gross, all right? Think it to yourself at least. All right, there we go. Delicious milkshake. Look at that. All right. So now we're going to go back on here so we can see all our experiments again. I'm going to keep mixing up my milkshake, okay? Now, I want you to think to yourself whether you think my milkshake looked good or if you think it looked gross, okay? That's all I need you to do. Now, the other thing, actually, I would like you to do is think about how you would describe my milkshake, okay? So if you had to describe my milkshake to somebody, what would you say it looked like, okay? I want you to think about the color. I want you to think about, I don't know, whether it looked thick and creamy or whether it looked watery. Think about all those things. And most importantly, think about whether you would like to drink my milkshake. All right?
As of right
So,
now, everyone is saying gross.
what? Oh, nobody likes my milkshake? Oh, man. Oh, all right. Well, that's okay. I'm going to leave it here anyway. And we're just going to set that right there. We're going to come back to it, okay? So you're all thinking about how you describe it, which apparently is gross. It's okay. All right. But we're going to come back to that. And we'll see how that's doing a little bit later, okay? Now, next thing we're going to do, guys, while we're waiting for that milkshake, okay, I want to show you another, wait, what's that? Something going on in my screen there with the milkshake. It looks weird. I don't know why it's doing that on my camera there. Anyway, guys, my milkshake is, whoa, look at the milkshake. It's real life. What's happening? Take a look, guys. I think my milkshake is making a chemical reaction. That's what I think. All right, so let me show you guys up close what that looks like, okay? We know this is a chemical reaction because it's mixing together and it's making lots of bubbles. You guys see that? So, lots and lots of bubbles right there. Now, whenever you mix things together and they start making bubbles, we know that it is a chemical reaction, okay, guys? So, that's how we can tell there. Now, we're going to do here, guys, we are going to take this. I'm going to hide it over here, okay? Because normally, bubbles will go pop. But these bubbles don't pop. So when it makes more bubbles, it just gets bigger and bigger and bigger and bigger until it's done, okay? So we're going to hide that right over here to the side where nobody can see it. And then we're going to see what happens when our milkshake is all done. Okay, now, while we're waiting for that milkshake, guys, we're going to go look at another chemical reaction, like I said. We're going to start with this chemical right here called water. I'm sure you've heard of that one. Now, we are also going to take another chemical that I have over here that is a type of crystal, okay? Now, crystals always sound very rare and exciting, but did you guys know that salt is actually a crystal? Yep, and so is sugar. So you guys eat crystals. Crazy, right? I don't want to eat these ones because these are not just any salt crystals, right? Regular salt is called sodium chloride, okay? That's table salt. This is called sodium hydroxide. It would hurt pretty badly if you were to eat this, so we're not going to do that. But what we are going to do is put it into my water. And you guys will see, just like if I were to put regular salt into water, I will mix it in, and it will start to dissolve, okay? Now, when we say something dissolves, we're saying that it starts to disappear into the water. Now, I like the word disappear, and here's why. When you say something disappears, it doesn't mean that it goes away. It just means that we don't see it anymore, okay? And that's a great way to describe things that dissolve. They don't go away, we just don't see it. Kind of like if you go to the ocean, you don't see the salt in the water, but you know it's there. Sometimes it gets in your mouth and you can even taste it, right? So dissolving does not mean it goes away, it just means we don't see it. And now, I think I've stalled enough saying that same thing over and over that it is finally all dissolved, and we can get on to a chemical reaction. And to do a chemical reaction, we need another chemical that I believe you guys have heard of before called aluminum foil. I have some right over here to the side, and I'm going to take this aluminum foil and I am going to rip it up a little bit and drop it into my water right there. So we're going to take that, fold it up some more, and then rip it and rip some more and rip some more, just like that. We're going to set all those pieces down on my table. I know you can't see them quite right there. And then I'm going to drop them into that water, and we're going to see what happens, okay? We'll drop one there, and there, and there, and there. And now let's see what happens to it, okay? We're going to swirl that around for a second. Let's look up close. All right, so our last chemical reaction, our milkshake made bubbles, right? In just a second, we're going to slow this one down and see if this one is also making bubbles or not. All right, let's see. Not much yet, although if you look closely, guys, you'll see some really, really tiny bubbles there, right? So those bubbles show that we are getting a chemical reaction, although it's not a very exciting one, is it? Well, that's okay. Here's what we're going to do. So these bubbles are very slow, unlike our milkshake bubbles, and they're very small. And also, unlike our milkshake bubbles, they pop right away. And when they pop, they start to release a gas. Now, gases are usually clear, right, or invisible, so we can't see it. But it is coming out of there, even if you can't see it. And to prove that, what I'm going to do next is take a balloon and put a balloon on top, okay? So even though we can't see our gas, we will, once we put a balloon on there, see our balloon start to fill up.
Dr. T, we lost your voice. Dr. T, we lost your voice. Dr. T? Dr. T?
Going.
All right.
Yes.
Oh, sorry. We lost your voice for a little bit.
Oh, okay. I'm sorry. Where did I leave off? Do you know?
You were shaking it and we couldn't hear you. So the gases are being released and going into the balloon, right?
Yep, they're being released and going into the balloon. Very good. Yes, I'm sorry about that. All right, awesome. So that should be what's happening there. Now, guys, that's going to take a little while, just like our milkshake. So we're going to put that off to the side, and we're going to come back to it later. And now we're going to do a really fast chemical reaction that we don't have to wait for. I bet you guys could use one of those, right? A fast one. Let's do it. So for our fast chemical reaction, we're going to take another one of these things here. And by the way, guys, this is called a flask, okay? In case you were wondering what these are called. All right? A lot of times people think they're called beakers, but those aren't beakers, okay? Beakers are actually, I can give you an example, one of these things right here, and we call this a beaker because it actually has a beak on it, just like a bird. That's how we pour things. So that's a beaker. This is a flask. And in my flask, I'm going to add a little bit of something called vinegar. All right, so I'm going to pour my vinegar right into there, just like that. Okay, so vinegar, as you guys know, looks just like water. You probably are familiar with vinegar. Maybe you've even done science experiments with vinegar, but you've definitely probably had it in food or stuff like that. So now, the other thing we're going to take is something right here called baking soda. All right, and baking soda will react with vinegar really, really quickly. In fact, it will react so quickly, I don't want to just put it in my vinegar. I'm going to add the baking soda directly to this balloon right here. And that way I can dump the balloon of baking soda into the vinegar and then see how fast our gas bubbles will fill it up. So we'll put that right here and we'll drop it into that balloon right there. A little more, should be good. And then we will take that. And once again, like I said, we will drop it into our vinegar. And let's get close for this one. I will bring it up to you right here. And we'll dump that in and it will start to make a really fast chemical reaction that will blow up my whole balloon. And of course, you can see lots of bubbles in there, right? And we'll put even more bubbles in there. Just dump it all into our balloon. You can see where all that gas is coming from. Here's my vinegar and baking soda making bubbles. All right. So lots of bubbles filling up my whole balloon right there. So this one started very quickly. It filled up the balloon very quickly. And then it finished very quickly. So we're going to let that settle on down a little bit. And the bubbles will start to go away and my reaction will be done. Okay. Now we're going to come back to that a little bit later once our other balloon is ready as well. Actually, while I'm up here already, I'm going to go check on that milkshake. Let's go take a look. All right, here it comes. Got the milkshake here. It's coming. It's coming. And there's the milkshake.
Oh my
Ooh,
goodness.
that looks delicious, doesn't it? All right, now watch this, guys. This is going to be so good. I'm going to take it back here. I'm going to show you how to eat the milkshake in one bite. Ready? Ready, set, and up. Uh-oh. What happened to my milkshake? Uh-oh, guys. Let's take a look and see what we made. This guy's right here is not a real milkshake, of course, right? This is not even a Gloop Glop milkshake. A Gloop Glop milkshake is actually something called foam. I'll bet you guys have heard of foam before. Okay, now in this case, guys, this Gloop Glop milkshake made a type of foam called polyurethane foam. All right, but you can think of it as something else. This foam right here might actually be inside the walls of the Mad Science Lab. In fact, it might even be inside the walls of your house right now. Can you believe that? Guess what, guys? This Gloop Glop milkshake foam is what we refer to as insulation, okay? And what that does is it traps all the hot air inside of our house during the winter time, so we stay nice and warm when it's cold out. And it also traps the hot air outside our house during the summertime, so we stay nice and cool inside. So that's what this stuff does. And in fact, guys, it's really useful because this reaction actually got extremely hot. That's right. It's kind of hard to tell here because I can't quite break this one open, but you guys can see the cup is bulging out a little bit. That's right. This reaction often gets so hot, it'll melt parts of the cup. So this is a really, really hot reaction. Does not feel hot to me because the foam traps the heat really, really well. Okay, so far we have learned that chemical reactions can make bubbles, right? We've learned that one a lot, but that's actually another sign. What I just showed you is that chemical reactions can get really, really hot, okay? So sometimes they get hot, and you figure if they can get hot, they can also get cold, okay? So some chemical reactions get hot, some get cold, some make bubbles, some can even change colors. All right, so let's take a look here. We've got some tubes of water right here. Actually, I'm keeping back here. We can see it a little better. There we go. All right, so we're going to take a little bit of water, or some of my color changing chemicals, and add it to them, okay? So first, I have a green color changing chemical right here. And this green color changing chemical has a little green person on it. And his name is Mr. Yuck. Now, of course, you guys do not want to eat or drink anything that has Mr. Yuck on it. So we will take this Mr. Yuck chemical and we will squirt it right into here and here. Change the color of our water a little bit. And then we will take this blue one, which also has Mr. Yuck, and we'll squirt it there and there. And then we'll take this red chemical right here that also has Mr. Yuck on it. Oops, there we go. And we'll squirt it here and here. Now, so far, we don't have anything too crazy yet, right, guys? That's basically what we would have expected. But let's see what happens then if we mix some other chemicals and see what a chemical reaction color change looks like, right? It's not the same as putting food coloring into water. If you put blue food coloring into water, it's going to turn blue. Not that crazy. If you put blue food coloring into water and somehow it turned yellow, well, there must be something else going on there, and we're going to figure out what that is. So in this case, we're going to take some more of our vinegar right here. We're going to put it into our blue chemical, right? And you'll see when I put it into this one right here, it will start to turn red, just like that. And then we'll take this blue one here, and when we put our vinegar in, that one will start to turn orange. And then we'll take the green one, and that one will turn red. And then we'll take this orange one, and when we put the vinegar in there, it will turn yellow. And then we will take our last two, which we saw, the green and the orange, and they will turn red or yellow and yellow. Okay, very good. So here's the thing, guys. That was pretty cool. The only way that would have been possible, though, for something red and something clear to make yellow would be if we have a chemical reaction, because red and clear obviously don't make yellow. Same with clear and green, obviously don't make red, but they did because we had a chemical reaction. Now, we're going to take a little bit of baking soda, which we know reacts with vinegar, so we're not going to use too much because we don't want it to fizz too much. And then when we do that, we're going to put some into here, and this yellow, oh, you did use too much. It didn't fizz too much, that's okay. We've got some red now. So we got red right there, and we've got our orange right here, and we've got our yellow right here, and we're going to go for the whole rainbow. Let's do it. Red, orange, yellow. Next, we want green. Let's take some baking soda, drop it in there, and that will start to turn green. And then we want blue. Well, we'll take this orange here, put some baking soda in there, and it will start to turn blue. And then finally, we want some purple. Well, to do that, I'm going to need some of those crystals I showed you earlier, and I will put those into there. And when I do that, this one will begin to turn, mix up a little bit, and now it will turn purple. And now we have all the colors of the rainbow made using chemical reactions. Okay, now, while we've been doing that, guys, we learned all the signs of a chemical reaction, although there's one I want to elaborate on a little bit, okay? So we learned about color changes. We learned about making bubbles. We learned about, we learned about ones that get hot and cold. And then finally, they can change states of matter, sort of like my milkshake, right? We started out as two liquids, and now we have what we call a solid, okay? So let's take a look here again, guys. We're going to put my tray right here, and I'm going to show you another example of something that can change states of matter. Now, a lot of times when we use that as a sign of a chemical reaction, it often means we're changing states of matter into something that's kind of weird, like kind of almost in between different states of matter, like usually something kind of slimy, right? That's always a sign of a chemical reaction in most cases. You mix some things together, they get kind of slimy. Now, slime is a little bit in between a solid and a liquid. We're going to see one way to make it. In this case, instead of taking gloop and glop and turning them into foam, we're going to go backwards. We're going to take a type of foam and turn it into something gloopy and gloppy. So to do that, I'm going to need some more foam because I don't want to ruin my beautiful milkshake. I'm going to take a different type of foam that we call styrofoam. We're going to set that there. Now, I've also got an ingredient right here called nail polish remover. I'll bet you guys have heard of that one, okay? Now, the main ingredient in nail polish remover is acetone. And acetone can destroy different types of plastics, okay? They're called polymers. Things where those molecules I told you about are connected to each other like chains are called polymers, okay? And nail polish remover is great at destroying polymer molecules. In fact, it's really good at destroying certain kinds of polymer molecules, like the kinds that make up nail polish or the kinds that make up styrofoam. So watch this. Move our tray up here a little bit. I'm going to put some of this nail polish remover in the cup, and any second now you'll see my cup will start to turn into slime, just like that. And we'll take a little bit more here. Rub it all the way around, and now my whole cup will start to melt into slime in a chemical reaction. We can also take another one here.
Dr. T, that looks super cool, and I will definitely do that with my son because he's super excited about it.
Oh, awesome.
We have about 10 minutes left, all right?
Perfect.
Even though
All
we're having
right.
so much fun with you.
Oh, that's awesome. I'm so glad to hear that. All right, guys. So don't worry. We will get through some really cool stuff in the last little bit of time we have here. All right. And we'll do one more here. My favorite way to do it is to make a spider web with it. And there we go. I love making the spider web. All right. Very good. So we'll mush all that up right there. And now my 3 cups have turned into slime. All right. So now we know all the signs of a chemical reaction. But guys, here's the cool thing. No matter what signs we see, all chemical reactions always make something brand new. So let's go back to 2 reactions we haven't touched in a while. We had right here vinegar and baking soda. But since chemical reactions always make something new, we no longer have vinegar and baking soda. Now we have this clear liquid down there called water. Bet you didn't know that. Vinegar and baking soda make water. But that's not the only thing it makes. One of the other things it makes is the stuff inside this balloon right here. Now, this stuff is really heavy, okay? It is a gas. It is just like the air, but it's heavier than most parts of the air. So it's not like helium, right? Because if we had helium, all I would do is let go of my balloon and it would fly. Well, that one doesn't have helium. No, this one is a heavy balloon, okay? Normally, even a balloon without helium would glide down slowly like this. But this balloon, guys, take a look. Yeah, that seems like a bowling ball. Yeah, that's a heavy, heavy balloon right there. Now, there is a heavy, heavy gas that might be inside my heavy, heavy balloon. And that heavy, heavy gas is called carbon dioxide. Now, you may have heard of carbon dioxide before. One thing you probably have not heard of carbon dioxide doing is putting out fires. So if you guys have ever seen a fire extinguisher before, a lot of those are filled with carbon dioxide. And so we can make sure and test to see if this is carbon dioxide by seeing if it can put out a fire right here. And here's how we're going to test that out. We're going to turn off our lights so you can see our flames a little bit better. And then we're going to take it and see if we can put it out. Ready? 3, 2, 1. And it explodes and the fire goes out. So we had carbon dioxide. Let's turn that light back on real quick. And now let's go take a look at my other balloon here. And this one, I'm going to tie that up. Now, we remember, guys, this one was trickier. Vinegar and baking soda is easy to remember. This one was a little more complicated. So this one we used water and aluminum foil and sodium hydroxide crystals. Now, we know it's not water anymore. We can see that. What we actually made down there is something called sodium aluminate. But we don't have to remember that. That's not really the important part. What's important is what's inside my balloon. So first, let's test and see if we have helium. As you guys know, helium balloons will fly. So let's see. Ready? 3, 2, 1. Look at that. My balloon can float. But wait a second, guys. Helium is not the only gas that can fly. In fact, here's a fun fact about helium, guys. It's actually a non-renewable resource. That means we can't make it with chemical reactions. We have to find it in the ground. And eventually, they might run out of helium. So if you're used to having helium balloons for your birthday, got bad news, guys. Maybe not for you. But by the time you're grown-ups, you may not be able to get any more balloons with helium anymore. We might need to save what we have left for important things like medical stuff. So you better enjoy it while you guys are kids still, okay? But the good news is there is another gas that we can make that also floats. And that would be something called hydrogen. And that's what I made right here. But there is one tiny issue with hydrogen. I'm going to show that to you right now, okay? The problem with hydrogen, guys, we're going to turn off our lights again. We're going to do the same thing we did with our carbon dioxide, okay? And we're going to see if it'll put out a fire. Now, carbon dioxide is great at putting out fires. Helium, if that were helium here, wouldn't really do anything. But hydrogen is kind of the opposite of carbon dioxide. Let me show you what I mean. 3, 2, 1. Whoa! Look at that. Yeah, that's the problem, right? So helium, it may not be great to use a non-renewable resource like helium, but guys, there's kind of an issue with using hydrogen too, right? Yeah, it kind of blows up. That would be a problem. Maybe you don't think so, right? But trust me, yes, birthday balloons blowing up would actually be a problem. Okay, well, let me show you one last thing here, guys, the couple minutes we have left. And I want to actually show you something really cool that's not even a chemical reaction. It's actually what we call a physical change, right? So if ice were to melt into water, that's a pretty big change. But it's not molecules coming together and trading atoms. It's different. You have the same exact molecule. You might have heard that water is called H2O. Well, ice is H2O. Water is H2O. They're both the same thing. Now, I've got another type of ice here called CO2. And CO2, grab some here, is a fancy way of saying carbon dioxide. And so I have ice right here that is so cold that it's basically part of the air frozen into ice. It's minus 110 degrees Fahrenheit. And if you don't believe me about how cold it is, it's so cold it will even make my spoon scream. There we go. Now, I want to show you something really cool we can do with this, okay? When I breathe on it, it will go back into the air as a gas like this, as you guys can see, okay? So it's really, really, really cool. Now, just like regular ice melts in water, carbon dioxide gas goes back into the air as carbon dioxide gas, all right? And that's why my spoon was screaming. All that gas was trying to escape from the ice, and it had to push the spoon out of the way. Now, the last thing I'd like to do with this, I'm going to take a few handfuls of this, guys, and I'm going to put it into this bucket. And what we're going to do is we're going to dump some boiling hot water on top of it. Now, when we do that, it's going to make it become a gas really fast. So kind of like I just showed you with my breath, but even faster. So that's 2. Let's get a third handful, and let's do number 4. So again, my breath can make it go fast like that. Now let's see what boiling water does, okay? So I know you guys are all at home, but if you had fun today and you enjoyed our show, then on the count of 3, I want you all to say science rules, okay? Ready? 1, 2, 3. Science rules. And now we get our giant cloud, all filled with carbon dioxide, plus also lots of water vapor. All right. Well, there we go, guys. I just want to thank you guys again for letting me join you today. It was so great to be with you. Eid Mubarak to everybody. I hope you guys enjoyed our show, and I hope to see you guys again sometime very soon. Thank you so much, guys.
Thank you so much, Dr. T. This was amazing. I appreciate all your help. Hopefully you guys liked it. I see all the science rules. All right, so that was the first half of our program. I will be signing off now, and I'm handing it over to Brother Talha. Brother Talha, are you here with us?
Yes, assalamu alaikum.
Wa alaikum assalam.
Jazakumullah khairan, Sister Sophia, for being the moderator in the first half. So my name is Talha Maksud, and I'm actually a former MCNA member. And alhamdulillah, now I'm part of YM now. MashaAllah, MCNA has helped me grow so much, and I learned so much about my deen through MCNA, and has helped me to become a proud Muslim, alhamdulillah. What I love to do